Dadong Lake Deep Tunnel Intelligent Robot. Product features introduction. The underwater robot system consists of 6 major systems: the underwater robot body, tether management system, launch and recovery system, the ground control system, the power supply system, and the emergency interception system. It can complete a 4.2 kilometers underwater inspection mission in moving water and sewage environments with low visibility. 1. Intelligent underwater robots. The underwater robot body is the platform carrying the underwater inspection device, responsible for real-time underwater detection. The robot adopts a modular design that allows for flexible deployment based on different needs. The ROV uses a cable-suspended motion mode and 8 thrusters, achieving full attitude design layout, enabling full attitude control with 6 degrees of freedom. Its navigation speed, attitude, depth, and distance are all controllable in real time. The positioning and navigation system can display the position information of the underwater robot in real time, and can also transmit and display the movement trajectory of the underwater robot in the tunnel in real time, and can also mark the location information of underwater abnormal points. The positioning and navigation system can transmit the position coordinates and movement trajectory of the underwater robot to the host computer display unit in real time, and has a real-time marking function. The Dadong Lake Deep Tunnel Underwater Robot will utilize multiple pipeline inspection technologies to form an innovative, integrated acoustic, optical, and electromagnetic inspection system to enable tunnel inspections in low visibility, high-velocity sewage environments. Under normal operating conditions, the system can detect internal siltation in the tunnel. The dredging tool can be rotated and extended to achieve local silt cleaning. 2. Umbilical cable and winch system. In this project, a constant tension cable laying automatic winch is used, equipped with a 4.5 kilometers umbilical cable. The cable has power supply and communication functions, and the optical communication transmission efficiency meets the data transmission and communication needs of underwater robots. The umbilical cable has a braking force of 2.5 tons and is resistant to bending, corrosion, tension, and wear, which can meet the requirements of deployment, inspection, and recovery under normal working conditions of the robot. The winch has functions such as real-time monitoring of cable tension and cable arrangement status, cable length counting, tension monitoring, speed control, and constant tension cable arrangement. It can automatically retract and release the cable according to the speed of the underwater robot's detection and match the cable tension to avoid entanglement of the umbilical cable underwater. When the cable tension exceeds the safe tension value, an alarm will be issued to remind the operator to handle it safely in time. 3. Deployment and recovery system. The deployment and recovery device consists of a deployment A-frame, a deployment TMS, a deployment cable winch, a manual quick lock, and a guide pulley, etc. It can realize deployment and recovery in vertical and non-vertical pods of the shaft. The Power TMS is equipped with acoustic and optical equipment for underwater observation. During the deployment and recovery process, the situation inside the shaft can be observed, which can realize the observation function of the internal situation of the shaft and the safe deployment of vertical and non-vertical paths. During the deployment and recovery process, no damage will be caused to the tunnel, shaft, and related equipment inside. 4. Ground control system. The ground control system adopts an integrated control room design scheme, using a 20-foot standard container equipped with a control console, display system, and data storage and transmission unit, multiscreen display unit, and power supply system. The multiscreen centralized control unit can control the robot operation, and the winch system can control the deployment and recovery system, simplifying the use of underwater robots on site. 5. Power supply system. The input power can be provided by 380-volt AC, 50 Hz mains or generator, with a total output power of less than 100 kVA. The output power is divided into 3 parts. The first part is 380-volt AC, 3-phase power, which supplies power to LARs and cable reels. The second part is 220-volt single-phase AC, which mainly supplies power to various electrical appliances in the integrated control room, such as display systems, control cabinets, air conditioners, etc. The third part is DC power, which mainly provides power for IOV and TMS. 6. Emergency support system. In case the underwater robot cable breaks or the robot body falls off, our company has designed an interception device at the end to prevent the equipment from entering the downstream pump station and affecting the safety of operation. The underwater robot body is equipped with a self-contained flashing beacon, which does not require external power supply during normal operation. Relying on its own energy storage unit, the flashing light can work continuously for 3 to 24 hours. During inspection, the underwater robot is deployed into the water from the inspection well through a special deployment and recovery device, and after passing through a vertical shaft of about 40 meters, it enters the main pipeline of the deep tunnel and uses video to record the structure to be inspected. Multibeam sonar is used to scan the tunnel's internal structure over a wide area, and it can also serve as a navigation sonar to guide the underwater robot's direction. When 3D circular scanning is required, the underwater robot T2250 software is opened, and the tunnel is entered to perform 3D point cloud data modeling and scanning. The intelligent robot for the sewage transmission system project in the core area of Dadong Lake can complete the inspection of dynamic water tunnels with a maximum spacing of approximately 4.2 kilometers in a single section. Through on-site surveys and design optimization, it has overcome difficulties such as the varying sizes of maintenance shafts, large differences in internal structures, complex flow fields in some maintenance shafts, long robot deployment distances, and complex paths. The inspection is completed under conditions of high flow velocity in the tunnel, no water outage or significant speed reduction conditions, and turns within the tunnel, providing a basis for the effective operation and management of deep tunnels in the future.